consider this problem. Find the general solution of y2 dash plus omega square y is equal to 0, where omega is a constant. y2 dash plus omega square y is equal to 0. This is an example for a second order homogeneous linear ordinary differential equation with constant coefficients, and moreover the characteristic equation have complex roots. In the last class we have considered problems where the characteristic equation have distinct roots, repeated roots and complex roots also. This is an example for the characteristic roots are complex conjugates. The given differential equation, what is the given differential equation? y2 dash plus y dash in the term illa, therefore we write 0 y dash plus omega square y is equal to 0. Then clearly it is a second order homogeneous differential equation, right side 0, and moreover which are the coefficients, or what are the coefficients? The coefficient of y is equal to omega square, y dash is equal to 0, and coefficient of y2 dash is equal to 1. That means the coefficients are constants. Or the given problem is a second order homogeneous linear ordinary differential equation with constant coefficients. Then, which is the general form? What is the general form of such an equation? The general form is y2 dash plus ay dash plus by is equal to 0. y2 dash plus ay dash plus by is equal to 0. Then compare the given differential equation y2 dash plus omega square y with the general form y2 dash plus ay dash plus by is equal to 0. Then comparing we have a is equal to the coefficient of y dash equals 0. What is b? B is equal to coefficient of y is equal to b is equal to omega square. Then what is the characteristic equation? The characteristic equation is lambda square plus a lambda plus b is equal to 0. That is lambda square plus a into lambda plus b is equal to 0. That is lambda square plus omega square is equal to 0 is the characteristic equation. And which are the characteristic roots? Lambda square is equal to minus omega square. And the root equation which are the characteristic roots? Characteristic roots are given by minus a plus or minus root of a square minus 4b divided by 2. Omega square is equal to, that is omega square, the characteristic roots are given by omega, lambda square is equal to minus omega square. This omega that is lambda is equal to plus or minus root of minus omega square. Root of minus omega square means root of minus 1 into omega square. What is root of minus 1? I. Omega square the root of omega. That is plus or minus I omega. See? Lambda is equal to root of omega minus omega square. That is root of minus 1 into omega square. Root of minus 1 is I. Then omega square like omega plus or minus I omega. Or the characteristic roots are given by lambda 1 is equal to the complex p plus I omega. Standard formula. What is p? The real part real part 0. Imaginary part of the omega p plus I omega. 0 plus I omega. That is lambda 1 is equal to I omega. And lambda 2 is equal to p minus I omega. That is p is 0 minus I omega. P plus I omega, p minus I omega, 0 plus I omega, 0 minus I omega. Therefore, the basis of solutions are, these are the basis of solution. y1 is equal to e raised to px into cos omega x. y2 is equal to e raised to px into sin omega x. That is y1 is equal to e raised to p 0x into cos omega x. E raised to 0 is equal to 1. That is 1 into cos omega x. That is y1 is equal to cos omega x. And what is y2? y2 is equal to e raised to px into sin omega x. That's equal to e raised to px in the value into sin omega x. That is y1 is equal to cos omega x and y2 is equal to sin omega x are two linearly independent solutions, or they form a basis of solution. Then what is the general solution? General solution is given by a into y1 plus b into y2. സാധാരണ നമ്മൾ c1 into y1 plus c2 into y2. ഈ കേസിനകത്ത് a into y1 plus b into y2. That is y is equal to a cos omega x plus b into y2. y2 ന്റെ വാല്യൂ ഏതാണ്? sin omega x is the general solution of this equation. That means it's an example for a second order differential equation where the characteristic roots are complex values, അല്ലെങ്കിൽ complex coordinates. Okay? ഇത് എന്ത് ചെയ്യാൻ കേസ് കാര്യം വെരി ഇമ്പോർട്ടൻറ്റ് പ്രോബ്ലങ്ങളാണ്. ഇതിനകത്ത് ഏതെങ്കിലും ഒരു മെത്തേഡിനകത്ത് എപ്പോഴും പരീക്ഷയ്ക്ക് ചോദിക്കുന്നതാണ്. ഇത് നിങ്ങൾ സേവ് ചെയ്യുക, എന്നിട്ട് നോട്ടിലേക്ക് പകർത്തുക. Can consider certain initial value problems which are examples of linear ordinary differential equation with constant coefficients and the characteristic roots are distinct. The second case, second type, repeated or double roots and complex roots. First one, consider this initial value problem. Solve y2 dash minus 2y dash minus 3y is equal to 0. Given y of minus 1 is equal to e and y dash minus 1 is equal to minus e by 4. Okay? An initial value problem with this condition. Y of minus 1. X is equal to minus 1 എന്ന് പറയുന്ന പോയിന്റിൽ the value of the function y is equal to e. And y dash minus 1 is equal to minus e by 4. That is at the point 1e, the slope is y dash. Y dash minus 1 is equal to minus e by 4. Okay? Then what is the given differential equation? The given differential equation is y2 dash minus 2y dash minus 3y is equal to 0. What is the property of this equation? It is a second order homogeneous linear ordinary differential equation with the constant coefficients. Like the coefficients are constants, y2 dash and y dash and y. Then which is the general form or standard form of such an equation. Such an equation, the standard form is y2 dash plus a y dash plus by is equal to 0. Then which is in the form, that is the given differential equation is in the form y2 dash plus a y dash plus by is equal to 0. That is second order homogeneous linear with constant coefficients, where a is equal to minus 2, the coefficient of y dash. What about b? B is equal to the coefficient of y is equal to minus 3. And what is the characteristic equation? The characteristic equation is lambda square plus a lambda plus b is equal to 0. That is lambda square plus a, that is minus 2 lambda minus 3 is equal to 0. Lambda square minus 2 lambda minus 3 is equal to 0. And the roots are the characteristic roots. Either you can solve this equation by using the results lambda is equal to minus a plus root of a square minus 4b divided by 2. ഒന്നുകിൽ ആ പ്രോപ്പർട്ടി എടുക്കുക, അതല്ലെങ്കിൽ എന്ത് ചെയ്യണം, ഇത് കൂട്ടിയാൽ minus 2 ഗുണിച്ചാൽ minus 3 കിട്ടുന്ന രണ്ട് സംഖ്യകൾ നോക്കും. Sum equal to minus 2 and the product is equal to minus 2. Which are the numbers? Sum is equal to minus 2 and product is equal to minus 3 are the numbers which are minus 3 1 ആയിരിക്കും. Well, lambda minus 3 1 plus 1. Lambda minus 3 into lambda plus 1 is equal to 0. That is, if lambda minus 3 is equal to 0, then lambda is equal to 3. The characteristic roots are lambda 1 equal to 3, and if the second term lambda plus 1 is equal to 0, then lambda 2 is equal to minus 1. That is lambda 1 equal to 3 and lambda 2 is equal to minus 1 are the distinct roots. Then which are the basis of solution? y1 is equal to e raised to lambda 1x, and then y1 is equal to e raised to lambda 1x. Here lambda 1 is equal to 3, that is e raised to 3x. and y2 is equal to e raised to lambda 2x. What is lambda 2 is equal to minus 1? That is e raised to minus x. Then y1 and y2, y1 is equal to e raised to 3x, y2 is equal to e raised to minus x. Then what is the general solution? General solution is c1 into y1. General solution is c1 y1 plus c2 y2. That is c1 e raised to 3x plus e2 e raised to minus x is the general solution. That is result here. Then what is y means y of x? Y is equal to a function of x and y is equal to y of x is equal to c1 e raised to 3x plus c2 e raised to minus x is the solution, general solution. Then what is y dash? This is another differentiate here. Differentiate either c1 into e raised to 3x derivative e raised to 3x, 3x into 3u. And then 3 c1 e raised to 3x. That is y dash x is equal to 3 c1 e raised to 3x plus c2. What is the derivative of e raised to minus x? E raised to minus x into minus 1. E minus x into minus 1 will. Then minus c2 e raised to minus x. c2 e raised to minus x into minus 1. That is negative. The given conditions are initial value conditions are y of minus 1 is equal to e. That means in this result, if x is equal to minus 1, y is equal to e. That means x minus 1 y e. Therefore, the initial value condition y of minus 1 is equal to e. That is a result. That is the general solution. Now y e. X minus 1. c1 e raised to minus 3 into minus 1 c e raised to minus 3 plus c2 e raised to x minus 1 plus 1. That is our equation. E is equal to c1 e raised to minus 3 plus c2 e. In other words, y dash minus 1 is equal to e minus e by 4. Why y dash x in another? X in another minus 1 y by another minus e by 4. Y dash minus 1 is equal to e by y dash minus 1 is equal to minus e by 4. That is minus e by 4 is equal to the e is certain now y dash x. Then y the y dash minus e by 4. X minus 1. 3c1 e raised to minus 3 minus e by 4 is equal to 3c1 e raised to minus 3 minus c2 e raised to minus of minus 1 c2 e raised to 1. This is result to 4 into 3. And that means 3 and 4 are equations involving the constants c1 and c2. Solve here. 3 and 4 are solve here. 3 and 4 are solve here. And you add here. 3 plus 4. And then 3 plus 4 gives 3 the left side e. 4 the left side minus e by 4. And then e minus e by 4 is equal to right side move. Then 3 c1 e raised to minus 3 plus c2 e raised to minus 1. 3 c1 e raised to minus 3 minus c2 e raised to minus 1. And e minus c2 e raised to 1 plus c2 e raised to 1. And the cancel. But 3 c1 e raised to minus 3 plus c1. Then 4 c1 e raised to minus 3. Okay? 3 and 4 would add e. Left side 1 in the e. Then the e minus 4. E by 4 minus e by 4. Now e plus minus e by 4 is equal to c2 e raised to minus 1 minus c2 e raised to minus 1 0. Baki c1 e raised to minus 3 plus 3 c1 either 4 c1 e raised to minus 3. This table is c1 is equal to the 4e minus e 3e by 4 and what they go on 3 by 16 e raised to 4. Okay. C1 is equal to 3 by 16 e raised to 4. Okay, from this C2 is equal to something else. Another simplify that. 13 by 16. Our values equation general solution. The general solution y is equal to C1 e raised to 3x. C1 is value 3 by 16 e raised to 4 into e raised to 3x value. E raised to 4 plus 3x plus C2 in the value 13 by 16 e raised to minus x is the particular solution. Okay. Another C1, C2 we solve it. Another result apply. This is save it. Save it. It's okay. Having complex roots for the characteristic equation. Consider this problem. Solve y2 dash plus 9y is equal to 0. Given y of 0 is equal to 0.2, y dash 0 is equal to minus 1.5. Minus 1.5. Second. Then the given differential equation is at the part of y2 dash plus 0 y dash plus 9y is equal to 0. Come on. This is in the form which is in the form y2 dash plus ay dash plus by is equal to 0. Or this is a second order homogeneous linear ordinary differential equation with the constant coefficients with the a is equal to 0 and b is equal to the coefficient of y is equal to 9. B is equal to 9. What is the characteristic equation? The characteristic equation is lambda square plus a lambda plus b is equal to 0. That is lambda square plus a lambda plus 9 is equal to 0. Or lambda square plus 9 is equal to 0. Lambda square plus 9 is equal to 0 means lambda square is equal to minus 9. Lambda square is equal to minus 9. Then what are the characteristic roots are? In the root lambda square is equal to minus 1, 9. Therefore lambda is equal to root of minus 9. Root of minus 9 is minus 1 into I, 3, 9 into 3. That is plus or minus 3a. That is lambda is equal to 0 plus or minus 3a. Real part 0, imaginary part is 0 plus or minus 3x. Then lambda 1 is equal to p plus I omega equal to p real part omega imaginary part. That is 0 plus 3a. And what about lambda 2? Lambda 2 is equal to p minus I omega is equal to 0 minus 3a. Hence, a basis of solution. Hence, a basis of solutions y1 is equal to e raised to px into cos omega x. That is e raised to 0x into cos omega. Omega is equal to 3. P plus I omega, p minus I omega, omega is equal to 3. Now, cos e raised to px means e raised to 0x. That is e raised to 0, 1, cos 3x. And y2 is equal to e raised to px into sin omega x. That is e raised to px means e raised to 0, 1 into sin 3x. Or y1 is equal to cos 3x and y2 is equal to sin 3x are two linearly independent solutions. Or the basis of solution is given by y1 is equal to the set y1 is equal to cos 3x, y2 sin 3x. Then what is the general solution? General solution is given by y of x is equal to a y1 plus b y2. That is a into cos 3x plus b sin 3x is the general solution. Okay. Then y is equal to a cos 3x plus b sin 3x is the general solution. Then given y of 0 is equal to 0.2. That means in this result, when x is equal to 0, y is equal to 0.2. That means x is equal to 0, y is equal to 0.2. Now y of x means y of 0.2. Y of 0. Y of 0 means 0.1. Now 0.2 is equal to y of 0 means 0.2 is equal to a into cos 3 0, that is cos 0 plus b sin 3 x in the value 0 sin 0 sin 0 sin 0 in the value 0 cos 0 and then 1 minus. That is 0.2 is equal to a into 1 plus b the value sin 0 the value 0 and down the time 0 or a is equal to 0.2. Okay. Then y of x is equal to a cos 3x plus b sin 3x. Then what is y dash x? Y dash x is equal to a into cos into derivative minus sin 3x minus sin 3x minus sin 3x into 3x again. Minus 3a sin 3x plus what is sin 3x derivative and then cos 3x into 3, that 3b cos 3x. Now y dash x is equal to minus 3a sin 3x plus 3b cos 3x. Even y dash 0 is equal to minus 1.2, 1.5. That means y is minus 1.5, x is 0. That is y dash 0 is equal to minus 1.5 gives y യുടെ വാല്യൂ ഇവിടെ y എന്നുള്ളിടത്ത് എന്ത് വരും minus 1.5 is equal to minus 3a sin x is 0 sin 0 plus 3b cos 30 അതായത് cos 0 sin 0 യുടെ വാല്യൂ 0 cos 0 യുടെ വാല്യൂ എന്തായിരിക്കും 1 എന്ന് വരും that is 3b is equal to minus 1.5 or b is equal to minus 1.5 divided by 3 is equal to minus 0.5 a കിട്ടി b കിട്ടി ആ a യുടെ b യുടെ വാല്യൂ എന്ത് ചെയ്യാം ഈ ജനറൽ സൊല്യൂഷൻ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യും therefore the general solution is given by the particular solution c1 c1 c2 ന് particular value ആണ് കിട്ടുന്നത് the particular solution is given by y is equal to a into a means 0.2 into cos 3x plus b ക്ക് പകരം minus 0.5 into sin 3x or the solution of the given equation is y is equal to 0.2 into cos 3x minus 0.5 into sin 3x. ഓക്കെ അത് ഏതാണ് കോംപ്ലക്സ് സൊല്യൂഷൻ അഥവാ റൂട്ട് വരുന്ന ഒരു പ്രോബ്ലമാണ് നേരത്തെ നമ്മൾ പറഞ്ഞാൽ എന്ത് ചെയ്ത് ഡിസ്റ്റിങ് റൂട്ട് വരുന്ന ഇത് കോംപ്ലക്സ് വരുന്ന കേസിനകത്ത് ഒരു ഇനീഷ്യൽ വാല്യൂ പ്രോബ്ലം ഇതും നിങ്ങൾ അന്നേരം സേവ് ചെയ്തിട്ട് നോട്ടിലേക്ക് പറഞ്ഞു